Inshallah, in today's class, we are going to continue with infinite series. Today, we are going to have the questions based on alternate series. First, we must know what is alternate series. You see, it is generated by sigma minus 1 power n minus 1 un. It will be equals to u1 minus u2 plus u3 minus u4. Alternate why? Because 1 plus 1 minus 1 plus 1 minus. So, this series, whenever you get alternate series 1 plus 1 minus, we say this is alternate series. And for alternate series, in our portion we are having Leibniz test. How to find whether it is convergent or divergent. If sigma minus 1 power n minus 1 un is an alternating series, and if two conditions are there for convergent. The first condition is un should be greater than un plus 1. That is, the series is a decreasing series. Un is greater than un plus 1. First condition should be un is greater than un plus 1. And the second condition is limit's value should be 0. If the limit n tends to infinity, un should be 0. If both this satisfies, then we say that the given series is convergent. Otherwise, if any one of this series does not satisfy these two conditions, then we say that the series is not divergent here. Alternate series is called otherwise oscillatory series. So what are the conditions? Un greater than un plus 1 and limit n tends to infinity, un should be equals to 0. Then we say that convergent. Otherwise, it is called oscillatory. How we have to prove un greater than un plus 1? We have to minus this one. Un, bring this here, minus un plus 1. We have to find this. If this is greater than 0, then we say that un is greater than un plus 1. We have to find un minus un plus 1. This should be greater than 0, positive now. If we get this minus positive, then we can say un is greater than un plus 1. So let me see the series, one of the series. So a small question is here. Whenever we see 1 plus 1 minus, then we have to show that this is it is which series? It is alternating series. This is the first thing. And what is the second thing? Just we can say what is the nth term. First, second, third, fourth, fifth, like that. Nth term will be un equals to 1 by n plus 1. You also find un plus 1 because we have to show the un greater than un plus 1. So what will be un plus 1? This is 1 by n plus 1. So we have to find un minus un plus 1. This should be greater than 0. Un minus un plus 1. Un is 1 by n minus this is 1 by n plus 1. You take LCM, n into n plus 1. This n plus 1 will come here, n plus 1 minus 1. Minus 1 plus 1 will get cancelled. And this nn will also get cancelled, 1 by n plus 1. You see here we got a positive number. This n is always positive, natural number. So this is a positive number that is greater than 0. Therefore, un minus un plus 1 is greater than 0. Bring this on the other side. Therefore, un is greater than un plus 1. So first condition is satisfied. The next condition is we have to find the limit. What we have to find? Limit n tends to infinity un equals to limit n tends to infinity. What is un? We are having 1 by n. Now if you substitute n here, 1 by infinity is 0. So we got both the conditions are satisfied, un greater than un plus 1 and limit value is 0. Therefore, we say by Leibniz test. This is called Leibniz test. Leibniz test, sigma minus 1 power n minus 1 un. This is the alternate series is convergent. If any one of these conditions do not satisfy, then we say this is oscillatory. Now see here, this is the question. So first we see that this is plus minus alternate. Therefore, first let me write that it is an alternating series. So for alternating series, we have to use Leibniz. For that, first let me write what is un. See, this is first term, this is second term, this is third term, this is fourth term. For first, second, third, fourth. For fourth term, you are having 4 here. So for nth term, it will be n. But here 4 means here 5 increased by 1, therefore n means here n plus 1. 4 5 3 4 increased by 1, n plus 1. So this is the nth term of the series. Now what will be un plus 1? In place of n you have to write n plus 1 plus 1, so it will be n plus 2. In place of n you write n plus 1 plus 1 n plus 2. The second thing is we have to show un greater than un plus 1. For that we have to find un minus un plus 1. Un is n plus 1 by n minus un plus 1 is n plus 2 by n plus 1. So let if we take LCM n into n plus 1. So this will get multiplied. N plus 1 into n plus 1 will become n plus 1 whole square minus this will come here n into n plus 2. Now you expand this. A plus b whole square is a square plus 2 b 2 ones are 2n plus 1 square 1. You multiply this minus into plus minus n square minus 2 plus minus 2n divided by n into n plus 1. So you can cancel this one. Plus n square minus n square plus 2n minus 2n cancel. What is left here? 1 by n into n plus 1. So we got a positive number. This is 1 by n. That means greater than 0. Therefore un minus un plus 1 greater than 0, or we can say un greater than n plus 1 un plus 1. What is the next method? We have to find the limit value. Limit n tends to infinity n plus 1 by n. So first you take common n from the numerator. You see here, limit n tends to infinity. If you take n common, you left with 1 plus 1 by n by n. N will get cancelled. You substitute infinity, 1 by infinity is 0. 0 plus 1 is 1. Therefore limit is not equals to 0. Therefore limit n tends to infinity un, we must get 0 for convergence. First condition is satisfied, but the second condition, limit value is not 0. Therefore we say that the series is oscillatory. Therefore sigma minus 1 power n minus 1 un is oscillatory by Leibniz test. You write by Leibniz test, sigma minus 1 power n minus 1 un is oscillatory. Now you see the next question. See, we are having by having 1 plus 1 minus 1 plus 1 minus. So let me first write that it is an sorry, the series is alternating. This is alternating series. So first we have to find the nth term. Suppose this is first term, this is second term, this is third term, this is fourth term. Fourth term means we are getting 1 power 1 more here. So for n you will get 1 by n plus 1. Whole cube is there for every term, so this will also contain cube. And this is for 4 to 4 means n, for n you have to go up to n, so on plus n. But you see here in previous classes you have learned this is called the sum to first n natural numbers. So its value will be n into n plus 1 by 2. It is the basic concept of previous classes. So let me substitute this sum to n terms, first n terms of natural numbers. So its value is n into n plus 1 by 2. N into n plus 1 by 2. Get cancel this one, you left with square here. So what is left? N divided by 2 into n plus 1 whole square. So this is un. Let me find un plus 1. So un plus 1 means in place of n you have to keep n plus 1. So this will be n plus 1 by 2 into n plus 1 will become n plus 2 whole square. Next thing is we have to show this is greater than 0, because we have to show un greater than 0, that's un greater than un plus 1. So we find this un minus un plus 1, this should be positive. So un is n divided by 2 into n plus 1 square. This is un minus un plus 1 means n plus 1 by n plus 2 whole square. So let me take the LCM now. If we take the LCM, it will be 2. Here also we are having 2 into just now see here what will be the LCM. 2 into n plus 1 square into n plus 2 square. So watch carefully. If you leave this here, this is left here, n plus 2 whole square into n, it will become n into n plus 2 whole square minus, you see if you left this, you left with n plus 1 square into n plus 1 will become n plus 1 whole cube. So see here, let me do one thing. You expand this a plus b whole square is a square plus 2a, 2 is 4 and plus 2 square 4. A plus b whole cube, you know the formula of a plus b whole cube. It's a cube plus 3a square b plus 3ab square plus b cube. So let we expand using this formula. A cube means n cube. 3a square into b is 1 into b means same. 3ab square. 1 square is 1 plus 1 cube is 1. So divide by, you write this as it is 2 into n plus 1 square into, though you multiply this one, n into n square will become n cube plus 4n square plus 4n. Now you multiply it minus here, so this will become minus n cube minus 3n square minus 3n minus 1. Now divided by 2 into n plus 1 square into n plus 2 whole square. Now plus n cube minus n cube will get cancelled. 4n square minus 3n square will be n square. 4n minus 3n will be plus n minus 1 by 2 into n plus 1 square into n plus 2 square. Now denominator is positive. N is a natural number, so minimum natural number is 1. Even if you keep here 1 also, 1 minus 1 will get cancelled, get left with 1. So this cannot be less than 0. This is always greater than 0 because n is natural number. So minimum natural number is 1, 1 plus 1, 2, 2 minus 1 is 1. So the minimum value of this will be 1. If you put n value greater, you will get more values. So this will not be negative, therefore we can say un greater than un plus 1. So next thing is we have to find the limit. Limit n tends to infinity un. So limit n tends to infinity. What is un here? We are having the value of un is in the board. You see, this is the value of un, n into 2 divided by n plus 1 square. We have to take common in the numerator. Limit n tends to infinity. N divided by 2 into, watch carefully. If you take out n common here, what is left here? Here it is left with 1 plus 1 by n. But we are having square, so we have to write square both here also, here also. Now you get cancel this one. Now if you substitute infinity here, you see here, this is 1 by infinity is 0. 0 plus 1, 1 square. This is infinity, so this will be 1 by infinity. 1 by infinity is nothing but 0. So both two conditions are satisfied. Un greater than un plus 1 and the limit value is 0. Therefore by Leibniz test, the series is convergent. The series is convergent. Now the C next question, minus 1 power n, whether n or n minus 1 or n power plus 1, whatever, minus 1, if you get here like this is alternating series. So let me write it is alternating series. Now what is un here? Un equals to 1 by 2 power n plus 1. So un plus 1 will be 1 divided by 2 power n plus 1 plus 1. So n plus 2. Now we have to see whether un is greater than un plus 1. For that we find un minus un plus 1. Un is 1 by 2 power n plus 1 minus n power, you see we can write like this, n plus 1 plus 1. This is, so we can write 2 power n plus 1 into 2 power 1. So let me take common here, or you take the LCM. 2 power n plus 1 into 2 is the LCM. So you get 2 here minus 1. 2 minus 1 is 1 divided by 2 power n plus 2. Again I am adding this. So this is a positive number. Therefore first condition is satisfied, that is un greater than un plus 1. So second condition is we have to find limit n tends to infinity un. Limit n tends to infinity un. The value of un is 1 divided by 2 power n plus 1. If you put infinity, 2 power infinity will be infinity. 1 by infinity is 0. 1 by infinity is 0. Therefore both conditions are satisfied. Therefore by Leibniz test, the series is convergent. The series is convergent. Now let's see the next question. What is it? Is an alternating series. Now un equals to 1 by n factorial. Un plus 1 means in place of n you have to write n plus 1. So this is n plus 1 factorial. We can change little, watch carefully. Suppose we are having 10 factorial. That can be written as 10 into 9 factorial. In that way, n plus 1 factorial can be written as n plus 1 u less by 1, n factorial. So n plus 1 factorial can be written as n plus 1 into n factorial. So we have to show un greater than un plus 1. So let me find un minus un plus 1. Un we are having 1 by n factorial minus this is 1 by n plus 1 into n factorial. Let me take LCM n plus 1 into n factorial. What will be here? N factorial, n factorial. Same, we have left with n plus 1 minus 1. Minus 1 plus 1 cancel. What is left here? N by n fact. You can cancel, but no need to cancel. This is the positive term, therefore un greater than un plus 1. Because negative get cancelled, this all the positive terms. Now next step is we have to find the limit. So limit n tends to infinity un equals to limit n tends to infinity. Un is 1 by n factorial. Infinity factorial will be infinity, only 1 by infinity is 0. Therefore, both satisfied. Therefore, we say the series by Leibniz test, the series is convergent. Now see here, x divided by 1 plus x minus x is 1 plus 1 minus, that is, it is an alternating series. It is an alternating series. Now u will be, this is first term, second term, third term, fourth term. For 4 you are getting power 4. So for n you will get the power n. And here also x power n. Also one thing is given in the question, 0 less than x less than 1. This is to be used here. What does it mean? The value of x lies between 0 and 1. It is given in the question, okay? It is given in the question. So next step is, what is un plus 1 equals to x power n plus 1 by 1 plus x power n plus 1. So we have to see whether un is greater than un plus 1. Let me minus this one. So what is left here? X power n by 1 plus x power n minus x power n plus 1 by 1 plus x power n plus 1. So let me take the LCM here. If we take the LCM here, this will be x1 plus x power n into 1 plus x power n plus 1. So this will multiply with this. I am writing shortly, x power n into 1. It will be x power n plus x power n into x power n into x power n plus 1. Since bases are same, if you add the powers, n plus n will be 2n, x power 2n plus 1. So come here, minus into plus, minus x power n plus 1 into 1 will be x power n plus 1. And lastly, you see here, if you multiply this minus into plus minus, x power n plus n will become 2n plus 1. So this plus 2n minus 1 plus 2n minus 1 will cancel. You see here, x power n plus 1 means x power n into x. Let me take common here. If you take x power n common, what is left here? 1. This x power n into x. So we have taken x power n common, is left with x divided by 1 plus x power n into 1 plus x power n plus 1. You see here, because x is lies between 0 to 1. What is given here? Since 0 less than x less than 1. So this value is lesser than 1, 0 to 1. So this will be plus only because x is less than 1. So this value will be greater than 0. 1 minus something less than 1 means it will be positive. So this will be greater than 0. Therefore, un greater than un plus 1. Now let me find the limit here. Limit x n tends to infinity, un equals to limit n tends to infinity. What will be un? The value of un is x power n by 1 plus x power n. You see here, we have a concept here. 0 less than x less than 1. Because x lies between 0 and 1, x power infinity is 0 here. X power infinity will be 0. If x is between 0 to 1 in decimals, then power, if we apply, you will get it 0. So x power infinity will be 0, x power infinity will be 0, 0 plus 1 will be 1, sorry 0, so 1 plus 0 1. So you will get the value as 0. Just remember this, x power infinity is 0 when x lies between 0 and 1. So x power infinity is 0, x power infinity is 0, 0 plus 1 1, 0 by 1 is 1. Therefore both satisfied, therefore the series is convergent by Leibniz test. So inshallah we will going to continue the next class, absolute convergent and conditional convergent, in the next class inshallah. I don't want to make the classes more than 30 minutes. Approximately, I will always try to complete the class within 20 to 30 minutes, inshallah. So, inshallah, in the next class, we are going to continue with the absolute convergent and conditional convergent. And always, I request to subscribe and share my channel, inshallah. We are going to continue in the next class.